Hey, I'm David Chaiken. I'm the chief architect of Pinterest. And first of all, I want to thank Mosin and Criteo for hosting this event. I've only been the chief architect at Pinterest for a few months, and so I've been talking about the material in this presentation for quite a while, one-on-one with people, and in previous roles, and in fact had a good one-on-one conversation with Mosin a couple months ago at Coupa Cafe right down the block, which is kind of the genesis for this talk. But this is the first time I'm presenting exactly this material, so thank you for attending, and thanks to Criteo for hosting. I am an individual contributor engineer. If I wasn't here right now, I'd be working with our spam team to optimize a query that goes through billions of rows per day and helps protect Pinterest from the bad folks out there. Another one of my hats is looking carefully at the efficiency of all of our systems, and in particular our data systems. So in addition to thanking Mosin, I should also thank Julian, who also presented for Parquet and all of the great systems that help us every day take really big data and chop it down to merely big data that's tractable for us to process. Okay, so just a word about Pinterest. Our mission is to help people discover and do what they love. What that means is we have this huge engine for going out and bringing in content and understanding that content and helping to make the process of people figure out what they want to do, whether it's a hobby or travel or style or building a house or anything, any area where people need inspiration to go find ideas. And then this do part is really important because although a lot of that discovery activity happens online, once people find something that they love, we really want people to close their computers, get out of the office, get out of the house into the rest of the world and actually do something. And we're kind of proud that given the way the world is right now, we really see people coming out of Pinterest happier than they went into Pinterest, and so that's kind of a point of pride for us. We try to make this process of discover and do absolutely as easy as possible and simple as possible for real people, but under the covers we support now 200 million monthly active users by really focusing on the underlying data ourselves. And really that whole process of discovery is supported by a lot of systems that look at what's out there on the internet and look at what people do with that information out on the internet and try to serve up the most relevant kinds of information to help people in their effort to discover. We've got, in terms of the basic data objects, we have more than 100 billion pins organized by real people onto more than 2 billion boards. We're very proud of the recent growth outside of the US, so 50% of the people who use Pinterest are outside of the US, and we're growing most outside the US, so 75% of our signups are now outside of the United States. So just to be a little bit more specific, here's another connection to Mosin's talk. It turns out that one of the things that I'm discovering with my wife right now is we're thinking about a trip to Southeast Asia, so it looks like I should ask Mosin for some pointers on going to Cambodia. And then some of my other interests are below there. Right. So a lot of this talk is called Business Intelligence Meets Data Science. So here's what I mean by business, at least in the case of Pinterest. Here's how Pinterest makes money right now. And I call this, when people ask me for a shorthand on how does Pinterest make money, I say, well, it's the digital media model. So how many of you in this room are in the digital media business? I mean, I expect the Criteo people all to raise their hands, right? And certainly some of the other folks. Okay, since this may not be obvious to everybody in the room, then I'll go through it. This number is weekly active users, which we use to measure the growth of the system. Impressions is a term from traditional media of a printing press coming down onto a page and impressing ink onto that page. That's been carried over into the digital world. We still call them impressions, but we get a certain number of impressions out of those weekly active users. We decide to balance the promoted pins on our site, which you can also think of as ads, with the total number of impressions on the site. In the business, both traditional and digital media, we call that ad load. There's some amount of money cost per impression that advertisers are willing to pay to promote those advertisements, and that results in money. The reason why I struggle with that M is because it's the M, meaning the Roman numeral M for 1,000, and again, this is a direct connection from the traditional media where things were sold. I've got evidence of ads being sold at least back into the 19th century in exactly the way we sell them today, but it's a Roman numeral M, and so we tend in the business to count in terms of cost per 1,000 ad impressions. Okay, so why did I go through how we make money? Again, the title of the talk is Business Intelligence Meets Data Science, and what we find is there's this phenomenon that I've started calling the split brain problem, where there's the big data systems on one side and the data science and the machine learning folk who are doing all of that hard work that it takes, for example, in our case, to make it easy for people to discover content out there on the internet. And the other side of the brain is the money-making side of the brain, the business intelligence, that equation that I just showed. So what I was planning to do was to go through how the split brain problem happens in kind of modern internet companies like Pinterest and a lot of the other companies here in Silicon Valley, and also to go through how does the split brain problem happen in more traditional companies. The reason why I know a lot about that is before I came to Pinterest, I worked at a startup called Altascale, and that was that provided Hadoop as a service and Spark as a service to both digital media and traditional companies. But then we were acquired by SAP. SAP's has a lot of customers in the Fortune 500. So I kind of got to see both sides of the story, both the companies that were born in the cloud, which get a split brain and problem in one way, and traditional companies that get a split brain problem in a kind of a very different way. To keep everybody on time, I think what I'm going to do is I'm going to cut down this talk, and the way I'll cut it down, the talk, is I'll try to focus on the companies that are more like the companies that were born in the cloud, the companies that we find in Silicon Valley, and I'll ask you in a few minutes a question to see if that's right. So let's start with the companies that were born in the cloud. Isn't it cute? All right. So how many of you are engineers who are building really big serving and data analysis systems in this room? Okay, good. I think that's probably the majority of the people in the room. But isn't it amazing that we live in a time where you can go onto a cloud like Amazon or Google or Microsoft and set this thing up and turn out an app, and you've got a business. it's just awesome that we can start this way, and this is often the way a lot of the smaller companies start these days. So you've got a user with an app on a mobile phone, an app server that's sitting somewhere in Amazon, Google, Microsoft maybe, and under that typically an open source relational database. The most common one is MySQL. And then to the extent that you need to do business analysis, if you're one person or two people in a garage, you just take the feed off of your MySQL database, for example, to figure out, well, how many users do we have right now, and hope that's more than your close family members. Okay, but it grows and it grows and it grows, and you wind up with something that I hope is familiar to a lot of folks in this room that looks more like this, right? Where you've got to support at least iPhones and Android phones and the web for our computers and the mobile web, especially for people outside the US. You typically, I hope, have some sort of API level that those apps talk to directly. That tends to be backed by a whole bunch of microservices, and then for your data layer, that grounds out not just in a single relational database, but typically a sharded relational database, plus also typically some key value store or set of key value stores, which I represent with NoSQL here. And then to make that efficient, there's some caching or search index systems that go on top. So I hope this thing is familiar to most people in the room. And then to do the analysis of what this thing is doing, sometimes at the scale of hundreds of millions, or for some of you in this room, even billions of people. You take all of the events or log entries or whatever is being thrown off of this system through a message box, which is these days more and more Kafka. Anybody from Confluent here? Confluent's right down this street. I tried not to put any brand names or anything in here, but when I'm speaking, I'll talk about some of the common ones. That tends to go into an offline analysis system where the foundation of the system will start with Hadoop. When I was at Yahoo about 12 years ago, I used to go into rooms like this and ask who's heard of Hadoop. I won't do that today. With either Hadoop or Spark or TensorFlow now, which tend to be the execution engines. Underneath they're the storage systems. Pinterest is on AWS, so we use a lot of S3. There are equivalents, of course, in Google and Microsoft. HDFS is another player typically down at that layer. At this layer, you have a number of different systems. So when I talk about streaming, Spark streaming is typical here. For batch, that's MapReduce, and frankly, a lot of people say MapReduce is going out, is being replaced by a lot of other systems. I don't know about you, but if I'm processing a few billion events received during a day, and I'm doing the kind of projection and filtering that Julian was just talking about a while ago, but doing it for billions or tens of billions or hundreds of billions of events, we're still using MapReduce for that. Hybrid systems like Tase, which is a good combination of the streaming and batch. And then, of course, neural nets and the machine learning stack that either sits on Spark or more and more increasingly sits on top of TensorFlow. Then the access engines, so SQL access engines like Presto, Hive, or Impala, or the data scientists tend not to use SQL for the work that they want to do. And then riding all the way on the top are a set of dashboards which come from companies like Tableau is really a leader in that area, but there's a whole bunch of companies, or more custom analytic systems. So what you wind up with are data scientists kind of riding in this area over here on top of this infrastructure, and then the business intelligence folks, the folks who are trying to figure out really how many users do we have, how much money are we making. They're trying to sit on top of this stack with more or less success. Right, and so then what happens as the company matures is you get a stack of software that looks a lot more like this, where yeah, you may be based on a cloud platform, but you have a much more traditional or classic approach to building systems, where you have a relational database from Oracle or SAP or Microsoft or IBM sitting at this tier, and then modules that sit on top of that either you're running yourself in terms of human resources, finances, financials, payments, customer relationship management, again with more dashboards and analytics on top of this separate stack for the business intelligence people, or as in the case of many of the new companies, you're even consuming this as a service. So you've got Salesforce.com for CRM, and you're buying these other modules from other companies. So what this results in is what I call this split brain phenomenon, where really the business intelligence folks want to live in this area, because they're thinking about how much are we making. If you're a public company, how much can we actually report out to the public and to shareholders and so forth? How many people can we afford to hire, or should we hire? How much should we be spending on infrastructure and so forth? And then on the other side, you've got the machine learning folks, and at Pinterest you've got product managers in this world who are studying the effect of experiments. If you're an advertising company, you may have 360 customer views in this kind of system, and have product marketing managers who are living in this world, and you really wind up with two different kinds of systems without a really good way to interconnect these things. So that's the story of split brain in kind of cloud companies, and the question here is, there's a totally different way to build computing systems and to provide services out on the internet. And if you're working for an insurance company or a bank or a pharmaceutical company, you're much more likely to have a structure that looks like this, right? Where the whole stack looks like that more financial oriented system for the cloud companies. You've got, again, this relational database system from Oracle or SAP or Microsoft or IBM typically. Storage that looks more traditional, like maybe something that's coming from NetApp or other more traditional storage vendors. You have an online transaction processing system, meaning the schemas and the modules that are typical of the traditional companies, and then a series of fairly monolithic apps that sit on top. So you could have payments. You can have any of the e-commerce applications that we interact with on a day-to-day basis. So here's the question. What I'd really like to know is how many people in the room have systems that look more like this kind of cloud computing at scale, and how many people in the room have systems that look more like this, where you take that online transaction processing and add in the online analytics processing. So if I was going to go through a bunch of slides in this area, for the folks in this room, how many of you would this really speak to your day-to-day life? Okay, I've got a few. And then for the other folks in the room, how many of you is this your day-to-day life? Okay, I really apologize to the few of you whose life looks like this in this room. Come find me, send me email. I'm Chaiken at Pinterest. I'm happy to talk about this. And when I was at SAP, this was my life kind of all day, every day. So I'm there with you, but I'm going to go with kind of the majority of the folks in the room and skip over a bunch of content because we're running a bit late. So anyway, the split brain problem happens in the in the traditional companies too. And there's a whole bunch of details on that are really interesting and was actually kind of behind why my last startup was acquired by SAP. But I'll skip over that for now. I'll also kind of breeze by almost all of these use cases except to re-emphasize a couple of points. One is, I've been waving my hands about dashboards and analytics and people at the top of the stack, and it's really important to think about the people who are using the system. So again, they're the business analysts. Sorry, let's start with business reporting. So this could be your sales force. This could be managers who are sitting on a manufacturing plant. This could be essentially anybody who really needs to know how your business runs, but they don't know how to write SQL, right? And SQL was obviously kind of the kicking off point for this whole NABD conference with Julian's talk, but the folks living at this layer want to know, how close am I to meeting the quarter for this month? Are we tracking revenue for the company? Are we tracking growth for the company? This is kind of the day-to-day and month-to-month business of running companies. The business analysts, they do know SQL. They're happy to pull a spreadsheet extract out of a system, but they're not going to go down to the level that Julian was talking and really understand formats and so forth. So these are the folks who are really putting together the numbers for presentations for that quarterly presentation, whether it's an internal presentation for the board of your company if you're private, or if you're public, reporting to the stockholders of your company. I'll skip through a bunch of these except to reemphasize that all of the roles in a lot of our companies, in particular this is true at Pinterest, everybody kind of stem to stern of the company is focused on using data to make the best decisions in their job. In particular, we've got Mosin mentioned hiring and teaching new machine learning experts. This is Jure Leskovic, who's a professor at Stanford. He's also the chief scientist at Pinterest. So I think about building systems that support him a lot, because at the end of the day, the ability for people to discover things on the internet at Pinterest relies on Jure and the other machine learning folks at Pinterest. And Jure does, to my knowledge, I don't think Jure spends a lot of time thinking about, especially about the revenue that we're making and making sure that the way that we calculate that revenue might be appropriate for reporting to our board of directors, or ultimately maybe someday to shareholders. He has a very different role from the previous roles that I talked, and he's absolutely as fundamental to the company as the people who are doing those business roll-ups. Okay, so keep your users in mind. The other thing to do is keep in mind the return on investment from the systems. And this is something I've been thinking about for more than a decade in this digital media world. And those of you who live the life in the digital media world know that there's a spectrum of different values per event. So event is someone looks at a web page, or looks at an image on a web page, or clicks on a web page, and ultimately generates some sort of, typically a log entry that's being processed by our systems. Or if you're on Uber, if you open the app, if you click on if you request a ride, all of the events from your ride and so forth, those are all events. Or if you're on Netflix and you're starting and stopping a video, those are all events. It turns out that they're just orders of magnitude of different values. So I understand those of you in the back who can't necessarily see this, but I've got the orders of magnitude here from about 1 penny, 1/100th of a dollar at this end of the spectrum per 1,000 events. So that's a very small fraction of a dollar per value per event, all the way up to if I get a lead for someone who wants to buy a car, or if I get a lead for someone who needs legal help. This can go easily up to events being worth individual events being worth $100 or even more than $100. At the same time, this is a perverse fact of digital media. There's this other order of magnitude where these things that are really valuable are really rare, and these things that are not very valuable at all are really, really common. So again, there's orders of magnitude from if you're doing real-time bidding on an ad exchange, you can process billions of these events that are worth very, very little every day. And if you're looking for leads for your business, if you're a law firm, those can happen only once a day or once a week or even once a month. So you need to be very careful about the value of these events. And just to connect that back over to Julian's talk, for example, every one of these events tends to be a row, and you need to be very careful about how you lay that out on disk or solid state disk or in memory to ensure that you're getting appropriate value, that the cost of storing and processing those events is commensurate with the value of the event itself. So I'll publish the slides here. This is just a quick back of the envelope calculation that you might want to do for just one small component of a data system. And the question I ask here is, if you want to store all these events in DRAM, dynamic random access memory, that's the more expensive storage component in our systems, it goes through and just does a back of the envelope, which is typically something that you might want to be doing even in a design meeting, just to get a feel for, okay, how much is the system going to cost on a per event basis? So what I do is I say, okay, if you go to Amazon Web Services and you buy a really large instance with almost half a terabyte of memory in it, which is a pretty effective way to buy to get access to memory, how much does that cost per year? And then given a specific size of event, let's say 10K, how much is that actually going to cost on a per event basis if you're going to be storing each of those events for a year? And this does, by the way, take into account that if you try really, really hard, I started with the list price from Amazon for on-demand instances, but if you try hard and get reserved instances, there's a 75% discount, and it bottoms out that even for this one component of storage, if you're trying to store events in DRAM, the cost per event is more than some of those lower value events that I showed on the last page. So this is kind of proof that with today's technology and the kind of systems that people actually use in production, you just need to be very careful about events that you're storing. I had exactly this situation with a very big brand. I guarantee you that there are a few instances of this brand, at least in this room. When I was at SAP, we need to work with this company and say, it's okay, don't try to store a certain kind of data in your most expensive kind of system. You got to get it out of that system into a lower cost system, because they were in a situation where essentially everything was breaking down for them. So I absolutely have seen this in practice time and time again. We do these kinds of calculations all the time at Pinterest. It's something that we need to be doing at all of the different kinds of companies that we work for. Okay, so this is my thesis. The solution depends on whether you start as a traditional company and build things up based on relational database management systems, or as a cloud company. I'm only going to cover the cloud side of this. So this is kind of a data flow viewpoint where you've got these events that I've been talking about flowing through logging systems, or tends to be Kafka in here at some point, and then that flows into some big data flow graph. The first time I really started to understand how complicated these things were when I was the chief architect at Yahoo, and someone showed me a wall-sized diagram with boxes like this, where every one of these boxes was an element in a data pipeline. MapReduce job, or a Spark job, or something like that, and it was wall size, and believe me, the boxes were much smaller than these guys, and the lines were much denser, right? So you wind up through organic growth, typically with some tangle of processing that you do. If you're lucky, it is a cyclic, but that's not even always the case. All right, so here's where we're going with this kind of thing as we go through this transition at Pinterest. Essentially, what we're doing is we're certifying different areas of our systems. Next slide will say what I mean by certified, but essentially we look carefully at our logging all the way back to the clients, and then we go into some part of this which amounts to our data warehouse, and we say, okay, we're going to look carefully at that and to make sure that the data that's being generated is sane. So, and then we put rules on that and say, okay, people who are looking at kind of top to bottom certified data, they can share data externally, and this makes the business intelligence folks happy. And then other people can still access data even though it's not certified, like our machine learning experts, but we say to them, okay, you're free to access the data, go derive signal, go make things easier to discover on our site, but please don't share the data you're using externally. What do I mean by certified? Make sure that the systems have service level objectives, so they're for delivery time, how often do the jobs run, are they running to completion, and completeness, meaning what % of the data gets processed. You always need to pay attention to security and compliance, but let me just say, for the certified areas, we pay extra special attention for the security of that data and the compliance of the data. You want those areas to be well documented, so people, especially the business intelligence folks, can find data by documenting the schemas, the size and shape of the data, the lineage, how is that data processed, and have, for that ROI part, make sure that the data is only retained as long as you need it. Conform dimensions and metrics. This is where the traditional world needs to come more into our Silicon Valley kind of chaos, where essentially you want to be very mindful about things like customer records and the accounts of customers and employee records, and things that measure what your product is doing, and make sure that data is standardized across your platform. And then finally, to make it tractable for engineers, provide common code libraries and usage examples of how to use those certified environments. This is our aspiration at Pinterest, is to essentially have a certified path that goes through this whole flow, from clients and serving down through the logging systems, even in the area where the data is sitting in its raw form as raw events, have some part of that be certified, then go through the streaming systems and batch systems and have those be certified when they're operating on structured data, and then be able to provide those dashboards not only to internal analysts and to business intelligence folks, but also to our users, if they're power users or partners who are working with us on our site. At the same time, we're not going to go and certify all of the systems that the statisticians we have and the machine learning experts are using, because that would drive them crazy, and they just don't need that level of rigor, and they don't want that level of rigor because they have the expertise to sift the signal from the noise here and really want to be able to execute rapidly. The trade-off here is, in this environment, for things to be certified, they need to run a little slower, and at the same time, you need to have folks who are turning the crank on agile development quickly. Right, and then I did mention this more traditionally structured system for running the business in a cloud company, and the point is, once you've built that certification into up through your structured data stores, essentially this is your granular operational warehouses and so forth, then you can connect those over to the more traditional systems and have all of those systems also be certified. So ultimately, the information that you're providing to your board of directors, shareholders, and so forth is certified and therefore as correct as it can be and secure and compliant. There's an analogy for this in that traditional world, and like I said, if you're interested in this, please contact me. To conclude, this split brain problem, I've seen this happen over and over again in the Fortune 500 and in the kind of companies that we've been building in Silicon Valley. I showed you for cloud companies kind of how to work through this and get to a solution, and some of the things that we think about. There's an analogy for that for the traditional companies. You have to keep in mind the return on investment as you go through and build these systems. You have to keep in mind the users and make sure that you're not driving the machine learning folks crazy with too much compliance, but at the same time you're delivering results that you can really trust for the business. And a friend of mine, when I was starting out on this big data journey myself, said something that was very useful. It's kind of a proverb, head in the clouds, feet on the ground, meaning I showed you what we're doing at Pinterest, right? We have this aspirational vision of where we're going, but we know we're not going to get there in one step. So we can see where we want to go, but in the meantime, we have a very pragmatic way of working through the logging systems and kind of the set of systems that we have already in place, and then understand that over time we'll move towards that more conceptual diagram of a certified path for data, and then the agile path for data. That's all I had to say, or approximately half of what I had to say, and I hope you enjoyed that.